Another way we can keep track of time is by tracking the cycle of the moon's phases. And you're probably all a little bit familiar with this already. But a month is defined literally by our moon. And there are two types of months. A sidereal month is the amount of time it takes the moon to orbit the Earth. And that's 27.3 days. Okay. And a synodic month is the time it takes for a full cycle of lunar phases. And for the moon to get through its full cycle from new moon to new moon again, or full moon to full moon again, it takes the moon 29.5 days to do that. So why are the two a little bit different? Well, again, it's all because our moon is moving around our Earth, but our Earth is also progressing in its orbit around the sun. And all of those make the synodic month a little bit longer than the actual amount of time it takes for the moon to orbit our Earth once. Let's say, for example, that we have new moon phase. And that's the phase of the moon cycle where the moon is directly on a line between the Earth and the sun. The sun is illuminating the back part of the moon, but not the front part of the moon. So we see none of the moon's surface lit up from our perspective, okay? And then we have a background star over here. Now we progress 27.3 days in our Earth's orbit around the sun. In that time, the moon has made one complete orbit around the Earth, okay? And so here's the moon back again. And so we see that the moon is still going to be aligning with some distant star way over here. But if we look at the moon from our Earth's perspective, it's not going to be quite a new moon because now the moon has changed position with respect to this straight line that we could draw between the sun and the Earth. And so we're going to get a little sliver still of the moon here after 27.3 days. And then we progress forward a few more days in our orbit to 29.5 days. And at that point in our orbit, the moon is then aligning directly on a straight line between the sun and the Earth here. And so then finally, we will be able to see a new moon phase again. So the moon has to make a few extra days orbit. So the moon has to progress a few extra days around its orbit of our Earth in order to get back to the new moon phase because of this fact that our Earth is also progressing forward in its orbit around the sun. Okay. So let's take a look at the different phases of the moon, give them some names, and then we'll explain why the moon appears to be being illuminated in different ways during the course of this, what did we say, 29.5 day cycle for the moon phase cycle, lunar phase cycle. So we start with new moon. New moon is where the sun is illuminating the back side of the moon that's away from us, and nothing on the front side of the moon is lit up from our perspective. So we see it completely dark. And then over the course of the first half of that lunar phase cycle, we are in a part of the phase that we call the waxing phase. Waxing means that the light part of the illuminated part of the moon is growing over time. And we have a crescent phase when we have more dark than light. So here we've got just a thin little sliver of the part of the moon being illuminated, and we call that the crescent phase. And as we're in our waxing phase, it's the right side of the moon that's lit up and the left side of the moon that's dark. Here we reach the first quarter phase where half of the right side of the moon is lit up and the other half is dark. And then as we go toward our waxing gibbous phase, the gibbous phase means that there's more bright part of the moon than dark. So now we have more than half of the moon lit up during a gibbous phase, but still the right side of the moon that's lit up and the left side of the moon that's dark. And then finally, halfway through that 29.5 day lunar phase cycle, we reach full moon, where the moon is fully illuminated by the sun. So it's light from the sun that's striking the moon and reflecting off the moon that illuminates the moon. That's what we're seeing when we see the moon, okay? And then after we have full moon, we go through what we call the waning phase. And in the waning phase, we are diminishing in the bright part of the moon that's illuminated. And so during the waning phase, we're going to be moving from full moon back to new moon again. Here, right after the full moon phase, we have the waning gibbous phase. So now it's the left side of the moon that's light, that's lit up, and it's the right side of the moon that's getting darker. So as we go through our waning gibbous phase, we still have more light than dark, but the dark side of the moon on the right is growing and the light side of the moon on the left is decreasing. And then we go through the third quarter moon, where it's the left half of the moon that's illuminated and the right half of the moon that's dark. And then we head on through our waxing crescent phase, where we've got more dark than light, and then eventually we have this little sliver here, okay? And all of that takes 29.5 days. Here again, we have our lunar phase cycle, and different phases of the moon appear in the sky at different times of day. So you've probably realized that too, that sometimes the moon appears in the sky at night, sometimes it appears in the sky during the daytime. So while we're moving through our waxing phase, going from new moon to full moon, the moon is visible in the afternoon or the evening time. It gets fuller every night, the more of the moon is illuminated every night, and it rises later each day, okay, as we move from new moon toward full moon. And then as we move from full moon back to new moon again, the moon starts to become visible in the very late night or the early morning. The moon gets less full and it sets later and later each day. Why do we see different phases of the moon during the course of the lunar phase cycle? Well, it's all because of the Earth, Moon, Sun orientation. So here we are in new moon, and at new moon, if we've got the sun over here on the right, the sun is illuminating the moon from the side of the moon that's opposite from the side that we see. So the sun would be illuminating the back side of the moon and not the front side of the moon. So we just see the moon to have a dark surface. And then the moon moves forward on its orbit. Over here, when we're at first quarter moon, this is the moon's position relative to the Earth and the sun. And so we'll see that the moon is being lit up, again, still from the sun on this side. But from our perspective on the surface of Earth, we're going to see the right side of the moon being lit up and the left side of the moon being dark. Then the moon comes over here through our waxing gibbous phase. It's growing, the illuminated part of the moon is growing. And then we get to full moon. During full moon, you have the side of the moon that's facing us being fully illuminated by the sun's rays. And then the back side of the moon, which we don't see, is dark. And then it comes around again to our last quarter moon or the third quarter moon. And from our Earth's perspective, then we would see the left side of the moon being illuminated and the right side of the moon dark. And then the moon moves forward again on its orbit all the way back through new moon again. So here is another slide that's depicting our sun, earth, moon relationship during the course of our lunar phase cycle. We've got this time the sun on the left, and during our new moon phase, we have the moon directly between the earth and the sun. And during this phase, we've got the sun illuminating the back side of the moon, but not the front side of the moon as directly. So you can still see the new moon a little bit up in the sky. It appears at noontime, crossing through the meridian when we have new moon. And then the moon moves forward on its orbit around the earth. And then here at waxing crescents, we look right here, you can imagine what the moon might look like from the Earth in this phase. But see, we have this dotted circle of our orbit around the Earth. So imagine that I chopped off right here where I'm moving my little pointer, and we're just looking at the part of the moon inside that circle that's facing the Earth. And so from our Earth's perspective, when we're in the waxing crescent phase, all that we see is this little sliver right here being illuminated by the sun. And then we see all the rest of it as being pretty dark. And then the moon moves forward again. Here we are at our first quarter moon. And so here then we see the right side of the moon being lit up, the left side of the moon being dark from our Earth's perspective. And we see first quarter moon appear in the sky right around sunset, that's twilight. And then we move toward our waxing gibbous phase. And then again, if I kind of connect the dot here, we see that everywhere inside this sort of arch that I'm drawing my laser pointer through, we will see from our Earth's perspective a lot more of the moon being illuminated and this little sliver of dark. So that's our waxing gibbous phase as we're moving from first quarter all the way to full moon. And then during full moon, we have the moon all the way on the other side of its orbit. And so the sun is fully illuminating the front side of the moon that's facing us. And so then we see the full face of the moon facing us being lit up. And full moon always crosses the meridian. That's that line going from north to south in the sky and going through zenith. The full moon always crosses through meridian at midnight. And then we move on toward our waning gibbous. So the bright part of the moon is diminishing. We're going more toward new moon again. And then we're progressing over through third quarter moon. Here in third quarter moon, from our Earth's perspective, we'll see the left side of the moon being lit up and the right side of the moon being dark. And then we go back to new moon again. This all has to do with the position of the moon with respect to the sun as it's orbiting our Earth that creates the phase cycle. Now, what I haven't told you is another key piece of information, and that is that our moon is in what we call a synchronous rotation with the Earth. Sometimes we say also that it is tidally locked, T-I-D-A-L-L-Y, tidally locked. And so that means that the same face of the moon always points toward the Earth all of the time. So as it rotates, that means that the same face of the moon always points toward Earth. So we are always seeing this side of the moon that you're seeing right here in this image all of the time. From our Earth's perspective, we don't ever get to see the back side of the moon, what sometimes you might refer to as the dark side of the moon. Although we know by talking about the lunar phase cycle that the back side of the moon does get illuminated by the sun. We just cannot see the back side of the moon from our Earth's perspective because that same side of the moon is always facing us. So that means that the moon rotates on its axis in the same amount of time that it takes to orbit the Earth. And we find that there are a lot of planets in our universe that are in a synchronous rotation with their star. That means that only one side of the planet is always facing that star all of the time. For us, that's not the case for our Earth because we are spinning on our axis and different parts of our Earth are facing the sun at different times of the day. But especially planets that are really, really, really close to their parent star, a lot of those planets are said to be in a synchronous rotation, just like the moon is in a synchronous rotation with us on the Earth. Humans have the tendency to see images of faces, animals, or other familiar objects in inanimate objects. And we find that throughout history, different cultures have seen different images in the dark and light spots on the moon. And so my question to you is, what pattern do you see in the side of the moon that is constantly facing us? So these dark parts on the moon are what we call mare, which is Latin for sea. It's essentially ancient lava flows. And these ancient lava flows make it such that that rock is less reflective than the other parts of the moon's surface. So in these dark spots, the light from the sun isn't being reflected back towards the earth as strongly. We will talk a lot more about the moon in future episodes, in future mini lectures. So we'll definitely hit upon these things again in the future. So this is the view of the moon as seen from the northern hemisphere, and then as seen from the southern hemisphere. So it's a little bit different, depending on our perspective on the surface of the globe. But here are 6 different examples of folklore and stories tied up to the patterns of the dark and light patches on the surface of the moon that cultures have seen throughout history. There are 6 of them. You can freeze frame and read more about them if you want. But for example, in East Asia, they see a rabbit in the moon. In the United States, we see the face, so we tend to talk about the face of the man in the moon. In New Zealand, one of the stories is that this dark shape here is a woman in the moon, a maiden who disrespected the moon and as such must spend eternity there as penance. In India, they see handprints on the moon. So maybe think about the next time you look up at the moon, what pattern do you see and what story does it tell you?